Hi, I'm Johannes. I'm talking about Gridfinity something that someone suggested to me who is not in this room. I should stress who is not in this room. To quote Karl Marx, religion is the opium of the people. To quote me, Gridfinity is the opium of the nerd, especially of the ADHD nerd. So that's what the talk is about. I want to stress in the beginning regarding food safety, don't pour chocolate directly into 3D printed molds. Please don't. Use molds made out of food-safe sheet PETG. Don't pour chocolate anywhere in. That's not food safe, please. And I'm not a food scientist. I don't know what they do. Please don't trust me. Do your own research. Don't sue me if you get, pneumonia. So anyway, I like chocolate. You probably too, hopefully. That's why you're here. So previously I gave a talk, and some of you listened to it at the Gulasch Programmiernacht that was called Creating QR Codes Out of Chocolate, in which I told you how to essentially do advanced rickrolling, where I showed you how to rickroll people using chocolate, which kind of worked as an event itself. It was pretty simple. You can find the talk there. It's recorded, and people liked it because I gave out free chocolate. And there were slightly more people in here. But back to Gridfinity. So there's a problem, of course. Normal chocolate is really terrible, especially the bars, because consider this. There's a bar. I have the wrap version here. You see I ate a little bit because, I don't know, I liked Rumtraubenuss. Of course, Rittersport. If you try it here, that's a normal Gridfinity grid. Doesn't fit. It's terrible, I tell you. The problem is here because Rittersport didn't know better, so it's no 24-millimeter grid. That's horrible. So let's make a Rittersport grid. To quote the overview of Google, a standard Rittersport bar is approximately 140 times 109 times 92 millimeters. So please don't trust AI on this stuff. Thank you. I can assure you that's not 9 centimeters thick here. Anyway, it's a little bit lighter. But essentially what we can do, we can measure it, because you already see that we can just put our ruler on this, and we can see that when we do a grid of 46 millimeters units, it works. It's really nice. It fits, so we have chocolate. We can say that's an advent calendar. And I have the version here too, so if you later want to see, just print your own, and thank you for your attention. Have a good night. Yeah, that's all of my talk. No, not seriously. I have another 60 slides left. 67 to be precise. But the problem is it won't fit our system, and it won't fit your system, because the God-given unit size is, of course, 42 millimeters. Douglas Adam gave us down in stone tablets. Anyway, that's why my talk is called essentially creating Gridfinity fitting chocolate. But you see later that we can actually build proper advent calendars with it. So first we create a base plate. That's pretty simple. Just go into a website like Gridfinity generators on. Click yourself a grid. That's like 6 times 4. And if my math is correct, that's like 24, which is enough. But the problem is, it's a little bit large, especially for my small 3D printer. So I used a 9 unit grid. That's quite fun. So we have here 3 stages that tell you in the following. We create a positive, we create a negative, and then we get chocolate. Those 3 stages of grief. Anyway, now first we do the positive. Essentially what we want to have chocolate, and you see here the finished product that fits our Gridfinity grid. That's pretty simple. We can easily build boxes that fit this grid. We just go to the box creator and it gets a grid box. The only problem is when we fill this with chocolate, it doesn't really work, it's a little bit too high, so we cut it into 2 halves, so we only get the lower part, because we don't want to have chocolate that's like 10 centimeters thick. Well, if you trust Google AI overviews, then we won't, but then we would also be using Elmer's glue for the pizza outside. Anyway, now we turn it upside down, and we put a square in the middle so that it's a bit stiffer. And the only problem is here, we cannot really grab it if it's inside one of these grids. So what we do, we just subtract a cylinder from this so we can easily grab it. That's what we have here. And yeah, that's all. A thing, we're now doing vacuum molding. And the idea is essentially we use this positive and put a sheet of plastic on top of it, and then we suck air out under it. So if our thing wouldn't be that simple as it is now, but would have more contours, then we would have need to put holes in, just essentially that the sheet can form it. But we don't have to. It's only important if you do things like QR codes. And if you do, just put 1.1 millimeter holes in, then your 3D printer can make them for you. And then essentially we 3D print them. That takes a while. And then you get this. And I have this grid also here. And you get this, and that's all fine, but you can't eat these. These aren't blue chocolate. Sadly, I don't have a chocolate 3D printer. So we get to the negative. We create a mold. It's pretty simple. We take a vacuum molder. The only thing is, you can build them yourselves, but I don't know, I wouldn't do because it takes time and it's not reliable. So what I did, I didn't spend the $1,200 on it, but I'm in a local makerspace called the Fab Lab Karlsruhe. It's a pretty cool place to be, and they have one of these there, which is really fun. And then what we do, we heat a sheet of PETG because PETG is like food safe and can be heated high enough that we can like pour chocolate in. And it's heated to 150 degrees, and then essentially we pull it down, and then we put it in. Can anyone see any problems with like heating PETG to 150 degrees? Yeah. The problem is the melting point of PLA they use below is 150 to 160 degrees Celsius. So PLA is pretty nice as 3D printing material because it's cheap and we need a lot of them. So I used anyway. You just need a lot of infill, so 80% infill, and it works. It only indents slightly, but you can see more in my other talk. Essentially, then we push it over, we pull out the air, and then we get these molds. That's pretty simple. We then wash and dry the molds. Anyway, we need to wash them because it's food, and we need to dry molds because chocolate really hates water. Then we need to create the chocolate, and we need to temper it. If we don't temper it, we get something like this, like grainy stuff. It's not really nice. It's still edible, still food, but this just happens when we like heat chocolate up and then cool it down. If you pour water in, it looks even worse. So what's tempering? Tempering is essentially the process of restoring the crystal structure. It sounds like a little bit esoteric, but essentially chocolate is like a macrocrystal, and we need to restore the crystal after heating it up so that it recrystallizes. And an easy way for this is, and that's the technique that I found online and that worked best for me, is we heat ground chocolate for 1 minute on like 600 watts in a microwave, and then in 10 seconds with bursts with 300 watts and steering in between until it is fluid. And we add a small piece of chocolate in and steer it in. And this restarts like the recrystallization. It's essentially like when you shoot silver ions into clouds, so they seed. Anyway, then we have another problem, air bubbles. The issue is that when you pour it in, then because you essentially with the steering in, you whipped air in, you have quite some air in, and you do this, and this is one of my first projects I did with vacuum molding. It was for a colleague of mine at work who depowered it. And you see that it's really ugly. It has air bubbles all in. How do you resolve them? Pretty simple. You vibrate this stuff. Essentially, you want to vibrate so that the bubbles go on top and then they pour out. You have two options. One is pretty simple. You have a 3D printer. It has a calibration mode, usually like for input shaping. You can just put it on there, and it should kind of work. The only problem is 3D printers aren't really food safe, and I don't know what the warranty says of pouring chocolate everywhere in. So the alternative is to buy a cheap vibration motor. I didn't. I just bought a dental vibrator table. I call it affectionately my dental vibrator or my chocolate vibrator, which is quite fun to tell colleagues that don't know what you do. Anyway, it's essentially a piece that dentists use when they have a gypsum molds, and when they put gypsum on and they want to remove the air bubbles too, and they put a sheet of like acrylic on top of it so that they have more space. The fun thing is how they work is pretty simple because they have just a large transformer in there. And with some coils, and then the metal plate essentially is like a motor and vibrates with like the 50, 60 hertz. It's pretty cool if you put this metal sheet away and then hold just a spoon or something on it, then it also vibrates and gets warm. Anyway, these you can buy, these are just vibration motors and build them yourself. And what you then do is you take your chocolate. I usually use cheap chocolate just because I'm still in the process of experimentation, and you shouldn't start with like a $4 100-gram chocolate. Anyway, you ground them down. The problem is when you ground them down, they get static electricity in. They fly everywhere. Just be warned. It will get lots of chocolates on you and your clothes and other people in your kitchen. Anyway, you then melt it as I've shown you before. Then you put in, as you see here, a slice of the bar in to steer it in, and then you can pour it. You use a piping bag. That's just simple because don't use spoons. It's just really messy, but you just pipe them in. Essentially what you can do, you can still vibrate the whole thing while you're piping in. Makes it easier. But then you get something like this, and you probably see here the air bubble. That's what I meant. These air bubbles come up. Otherwise you would have had it maybe below on the bottom where people can see, or in the middle, which isn't also that great. Anyway, we wait till solid because, we can't put this anywhere in. We wait till solid and then a little bit longer. One of the biggest mistakes that I always make is pour it out, get it out of the fridge too early, and then it breaks, and then it's sad because then I have to eat more, then I have to drink more chocolate milk. Because essentially, what do you do with all the broken up chocolate? Even if you messed up the tempering, just pour it into milk and cream, and it's really nice, especially when it's now gloomy like here. Anyway, we then get these here, and don't ask me why they have spotty places. I don't know. It's probably because something chemistry or something physics. I don't know. But essentially, they look like this, and they already fit Gridfinity. It's pretty cool. But I've told you before, food safety, and so it's not a good idea to pour them to put them directly into this into your Gridfinity because, especially if you have them in your workshop, they might get more than just some grease on. Anyway, you can just wrap them in cling film and it's fine. That's the cheapest solution that I found and also the easiest. And you see here now it's fully functional. You can just grab it out. You can store it. This is a good way to store your chocolate if you don't like Rittersport, because Rittersport, as you see, it's already Gridfinity capable. But this chocolate, this way you can make every chocolate Gridfinity capable. And that's very cool. So you might ask, where's the advent calendar? You've shown me how to make Gridfinity chocolate, and it's already really good. And I can tell you, it's nice, especially if you want to troll people out to your local makerspace. Just remove the tools, insert chocolate, and they will have fun. Especially because you can mold chocolate, you can just vacuum mold normal pieces like, for example, wrenches. Just put them in. Get a Petri sheet over, and then you can create chocolate wrenches, which is real nice. Anyway, where's the advent calendar, you might ask? It's coming now. You first take a picture. That's a picture from Rastatt. They have a really nice castle with a real nice church. Really recommend going there. It was just a nice picture that I had lying around, and I needed to print something. And then what's real helpful is if you don't cut them by hand, because cutting by hand takes quite a while. So what I did, of course, I went to my local makerspace. We have a Cameo 4. It's like a cutter. We can essentially cut paper and also other foils automatically. It's very cool. So in the software, which is really well usable, you can just design this grid, and then essentially it cuts there. And what's funny is that these normal photo papers, it is really strong. I only need the few bits there that are white in the lines, and it holds it. And that's pretty cool. It's really weird. I did more in the beginning. I had more places where it connected to the beginning, but I couldn't pull it open with my thumbs. Anyway, then you put it on, then you just start cutting, and yeah. And then you have this, and then you essentially like can lay it on top. It's currently more like a jigsaw, but then you take some glue, put it on, and that's all. And that's the thing here. It's a fully functional. Of course, it's not 24, but essentially that's here. That's a fully functional Gridfinity advent calendar, and you can remove it. You can eat the chocolate, and it's cool. Place it anywhere because it's compatible with your 42 millimeter unit size. But wait again. If some of you have read the abstract to my talk, I wrote there that I use 3D printing for the grid, done. Vacuum molding, done. Laser cutting for the frame. Do you see any laser cutting here? Do you see any frame? I thought like, nah, you won't buy this. You will be angry. So I'm of course thinking, how can I include laser cutting in this? You can't laser cut chocolate. Don't try. I wanted to, but people said no. Don't engrave it. It could be fun, but it could be also messy because I think a laser is slightly hotter than 40 degrees Celsius. Anyway, so the only option was to rethink everything. And the other problem that I had with this solution is, well, this is pretty cool for nerds, as you all here are probably, but it's not really cool for non-nerds because they don't know Gridfinity, they don't know the joke, and they are really confused why you put chocolate in like some sheet of plastic and put it on and find it funny. Anyway, it's like me having the Tannenbaum book, like I think it's the book on Minix, the operating system that preceded Linux, having it on my countertop and then telling my parents, let's put the presents below the Tannenbaum. They didn't get it. Sadly. Anyway, let's do this laser thing. And it's pretty simple. What you do is we create a chocolate advent calendar. So it's the third talk in this single talk. Anyway, what we want to do is we essentially create this here. It's a proper advent calendar. It's a proper advent calendar. People that are non-nerdy still understand it because it looks like a normal advent calendar. And how it works is pretty simple. We laser cut the frame. You see it here. And we laser cut this after we designed it with the laser cutter at the local makerspace, of course, and then we glue it together. And because I made mistakes doing this a couple of days ago, I tried to glue it. Essentially, I started with wood glue. It didn't work because laser cut edges. Then I tried instant 1 second glue. It didn't work. Then I was really desperate and tried hot glue, and well, it worked. Don't judge me. And no, it should be like kind of rectangular, but don't judge me. I'm a software engineer. I'm not a glue expert. Anyway, what we then do, I already pre-made these chocolates, and I made more of them. I don't know why. And what we then do is just use the same technique, essentially glue them behind the back. And the idea is here, because the frame and the paper is connected, it's stable enough. As you see here, we can like push on there, and it won't break. Well, some broke during transport, but yeah, and then you can just open them and like push this in. Well, you see, it's still work in progress. Oh yes, because I glued it down so it doesn't fall off. Anyway, you just pour it in and then you can grab it out. Get out. You shouldn't glue too much. I was really, yeah, it works. You see, it's like software engineering. It just needs to work. Anyway, that's all. This is very cool because this is usable, as I said, by non-engineers because they understand how this works. They probably won't understand why this works. They're like, and that's all. I think 20 minutes for like 85 slides is pretty good. So you have time to ask me some interesting questions. But I wish you happy crafting. I hope you have a nice day here also at the conference. If you want to read more on these projects or the things that I else do, you find me on mostly.nerdless.de, where I publish posts on mostly OpenJK, Java, whatever open source stuff. And I sometimes do also more complex chocolate molding tasks like this, where I use silicone to create something quite interesting. Anyway, that's all. It went faster than I expected, but I hope you still liked it, and now I'm open for any questions.
Have you tried vacuuming the chocolate instead of vibrating?
Oh, yeah, I thought about vacuum. The only problem is that the vacuum box, like the vacuum pot, is round, and I would have to cut it down. And I don't know. I might be thinking about it. The only problem is also it takes much more time to get a vacuum up than just vibrating it. So I don't know. And I wouldn't trust our vacuum pump that it's food safe, if I'm honest, because the vacuum, I can clean like my vibration table, but the vacuum pump and the vacuum pots, I don't know. I don't want to have silica foams in there. So yes, you could try it, but I fear also the chocolate might boil because we're lowering essentially the boiling point. Maybe, I don't know how chocolate liquid works. Would need to consult with some chemistry people, but yeah, it could be. But the cool thing is with a vibration table, I can pour it in while it vibrates, so it also fills out the form, which is pretty nice. So I don't have to be that precise. Yeah. Any more questions? Okay. Yeah. Thank you for this short and hopefully interesting talk. I'll be here for another 10 minutes. If you want to eat some chocolate, I have a bar of Traube rum Nuss here that fits in Gridfinity. Have a nice day at the conference. I think it probably would still last like a few hours. And maybe see you at next GPNs.